So yes, what the author says is false. The Copenhagen Interpretation does not suggest in any way that the world itself determines the way it's going to be. It says that when we make a measurement, that in one of those cases that I talked about earlier, where there's a 50% chance of the two events occurring, Copenhagen Interpretation says that when you make a measurement, you do what's called collapsing the wave function. Anyway, it gets technical, but you can read about it if you'd like. But the Copenhagen Interpretation says that when you make the measurement, at that moment, that's what determines the fact of the matter. That's the moment at which either the one event happens or the other event happens. Why do people believe quantum mechanics at all? Well, because it's the most accurate physical theory ever devised, ever created by humans. Okay? That's a very impressive claim. Right now, the major two pillars of modern or contemporary physics is general relativity and quantum mechanics. You have four forces in the universe. You have gravity, which is taken care of by general relativity. Then you have the strong nuclear force, the weak nuclear force, and electromagnetism. And quantum mechanics handles all three of those and gives the most accurate results of any other theory. After all, it is the math that has been so successful. The math is what we have to thank for the tremendous explanatory power, to use a phrase from Thomas Kuhn, very famous philosopher of science. But the math of quantum mechanics is what is so impressively accurate. It has nothing to do with the interpretation. So I wonder if there's people who look at who don't realize that. I wonder if there's physicists who don't realize that there are multiple interpretations of quantum, and they hear of people not believing the results of the Copenhagen Interpretation of quantum mechanics. And I can see these physicists saying, well, what do you mean you don't believe it? Look at the accuracy of the math. But if you don't make this distinction in your mind between the math and its interpretation, and which seems like it'd be pretty easy to do actually, if you just think about the math in terms of the interpretation, then you may not think of yourself as interpreting the math in any particular way. You just look at the notation and you say what it means. But yes, if these physicists are simply instrumentalists and say which interpretation of quantum mechanics is true, that's for philosophers, that's not physics anymore. If you're an instrumentalist and you say the job of the physicist is to come up with an accurate theory, which is very different from a true theory. For instance, Newtonian mechanics, very accurate, but it's false. It fails at high velocities. That's when you need special relativity. One extremely odd implication of the math of quantum mechanics, something that is truly entailed by quantum mechanics, by the math of quantum mechanics, yes, the thing that we should be respecting so much because it is so accurate. One necessary result of the math is that the universe is non-local, which is extremely strange. That's a lot of what Einstein didn't really believe about quantum mechanics. He thought that was so strange that quantum mechanics could not be true. So, evaluating theories by saying it's so counterintuitive, I don't believe it, that's probably not a good way to go about it. So I understand why when certain physicists are defensive and say, you don't believe the results of quantum mechanics, look how accurate it is. But again, like I said, most of what's strange is a result of their favorite interpretation, not a result of the math itself. So yes, according to the math of quantum mechanics, the universe is non-local. What does that mean? It essentially means that there can be influences between spatially separated systems. So normally, and this is what Einstein famously called spooky action at a distance. He just couldn't believe that the universe is non-local. But according to quantum mechanics, it is. So normally when we think of how the world works, we think of, well, of course you can't influence something without coming into contact with it, right? Or A can't affect B into B, or maybe A runs into X, that bumps into Y, that rams into Z, that hits B. But according to quantum mechanics, this is not the way the world works, at least not always. So apparently, in certain circumstances, what is occurring far, far away can instantaneously affect what is going on right here, right now, which is very strange. And that's why Einstein didn't believe. Thanks for watching. I provided many links to other information on quantum mechanics and various technical terms and people that I've mentioned in this video. So thanks for watching. Their links are in the video description.